100 points, yes.
Is the class on points or percent?
It's on points. Everything is points. That's why a test is 100 points. It's 5 times more than a quiz. Yeah. Yeah. Okay, let's go over last night's homework. And if you're still struggling with the trig values, you have to sit down and you just gotta study it. That's what you gotta do. Now you gotta put in the hard work now, because like I said, the whole course is based on it. So after this speed quiz, I mean, if we're still struggling, then you're just gonna have to pick it up slowly, but then you're gonna be struggling throughout the thing, because you know after this chapter, you know what we're gonna do? We're gonna be graphing. So how do you graph? You gotta plot points, right? So you're gonna plot points. So like if you're gonna graph y equal cosine x, then you gotta go, okay, what's cosine of 0? What's cosine of 5 or 6? You can plot the points. So if you don't know your trig values quickly, then how are we gonna graph? It'll be difficult, that's right. So, and just believe me, the whole course is based on, like I said, it's not gonna be just, oh, we study this and we go on to something else. No, you need it for the entire course. Okay, what was last night's homework? 7.5. Is that right? No, 7.2, fool. 7.2. Okay, read me, tell me which ones we're doing. Go.
47.
47. I find that hard to believe. That's the only one we need to go over.
51.
51. 55.
53.
Are you guys even keeping up with your homework? All the homework will be collected on the day of the test now. Okay, let me tell you how I check homework. Now some of you will be going, all right, he's only going to collect on the day of the test. Let me just go into the night before and do it all. I laugh at you right now if that's your strategy. Because it ain't going to happen. You can try. So what I do is, okay, it's 5 points per assignment. So how many assignments have we had? Unit circle worksheet. And then we got that, 3, 4, 5, the practice test, 6. So there's 6 assignments, so your homework is gonna be worth 30 points. When I will go through your homework, it's gonna be -1 for each one wrong. Now when I collect it, I already told you this, when I collect it on the day of the test, I correct it for correctness, not just effort now. Gotta be correct, so every problem wrong is -1. So like for these 6 homeworks, how many problems do you think you did? Maybe 100 problems. Okay, so if you get 30 wrong out of the 100, then you're down to 0 already on your homework. That's why. Ask questions. I try to assign the odd ones, right? You got the answers in the back. Ask questions and then you can write it down on your homework. That's why. Ask questions. Is this it?
10.
10. Oh, now they're coming up.
This is 59.
See, I have to give the lecture and then now they come up. Which is fine. I'm willing to do these. These in class, no problem. Okay, what's the smallest one? 10? Where's 10? True or false? It's a 50-50 chance. Tangent of pi over 5 is equal to cotangent of 4 pi over 5. Now, what did we learn last time? If 2 angles add up to 90 degrees, then the tangent of one is equal to the cotangent of the other, right? What happens if I add those 2 angles up? Do you get 90 degrees, which is pi over 2? If you add these 2 up, what do you get? Pi. Pi is 180 degrees. Now, what did we learn last time? If 2 angles add up to 90 degrees, then the tangent of one is the cotangent of the other. The sine of one is the cosine of the other. The secant of one is the cosecant of the other. Do these 2 add up to 90 degrees? No, they add up to 180. So that theorem doesn't even apply. However, it still might be true. You know what I mean? So you gotta check. But you can tell, okay, how do I know, just by looking at this, it's false. What quadrant is this angle in? Where is pi over 5? Did you guys at least convert this to degrees if you have hard time? What is pi over 5? If pi is 180 degrees, what's 180 divided by 5? Oh my gosh. 36 degrees. 36 degrees is somewhere over there. What is tangent in the first quadrant, positive or negative? It's positive. Now, where would 4 pi over 5 be? What is 4/5 of 180 degrees? Okay, how about this way? Pi over 5 is 36 degrees. What's 36 times 4?
20.
What?
Wait.
My dog can do better multiplication than that. 30, okay. This is how my kindergarten teacher taught us to multiply by 4. If you have a number and you want to multiply it by 4, you multiply it by 2 twice. That's what my kindergarten teacher said. Yeah, because everybody can multiply by 2, right? In their head, right? What's 36 times 2? Times 2? See, you did it! I knew you could do it. This is 144 degrees. Where's 144 degrees? It's somewhere over here, right? So what is cotangent in the second quadrant? It's negative, right? Because tangent and cotangent is flip over tangent, right? Tangent is positive here and here, negative there and there. So this is a positive number, this is a negative number. Can they be equal? No. So that's why it's false, right? But remember, when two angles add up to 90 degrees, the sine of one is the cosine of the other. That's what these identities are. This is what we learned last time. Here, look. When these two angles, see these two angles right here add up to 90 degrees, right? What is pi over 2 minus theta plus theta? It's pi over 2, it's 90 degrees. When two angles add up to 90 degrees, the cosine of one is the sine of the other. The tangent of one is the cotangent of the other. The secant of one is the cosecant of the other. That's what we learned last time. Okay, next, 47. Oh, so we just skipped that, huh? 47. Here we go. 47. 1 minus cosine squared 20 degrees minus cosine squared 70 degrees. Okay, I admit this one's not that easy. Okay, so the first thing I'm going to do is either I'm going to change, okay, look, you got to know your identities. Okay? Also, we learned last time the Pythagorean identities. Cosine squared plus sine squared is 1. 1 plus tangent squared is secant squared. Cotangent squared plus 1 is cosecant squared. Okay, which one do you think we're going to use in this one? Since I see cosine there. Which one of these three has cosine in it? The first one. So you got to be thinking here. Cosine squared plus sine squared is 1. Yo, Mr. Park, I don't see a sine. Well, what did we learn? When two angles add up to 90 degrees, the cosine of one is the sine of the other. So do you want to change this one to sine of 70, or do you want to change this one to sine of 20? It doesn't matter this way. Pick one.
First one.
Okay, so I can change this one here to sine squared 70 degrees, correct? Yes? Hey!
Right.
Hey! Okay, now does anybody see something? Hey, it kind of looks like that, but Mr. Park, got negative signs over here. So what you do is you factor out the negative sign. What happens if I factor out the negative sign? Like that. Hey, you somebody! Hey, you somebody! That's 1! Right there. Sine squared theta plus cosine squared theta is 1. These are identities. Again, what is an identity? It's an equation that's true all the time. It doesn't matter what angle you put here. If you put 70 degrees, 38 degrees, 42 degrees, it's going to be 1 every single time. And so what is 1 minus 1? It rhymes with 0. Changing. Kikaida.
Kinda.
You guys know Kikaida? There you go. Now, I admit that's not that easy because you gotta go, oh, I gotta use the co-function identity, and then I gotta factor out the negative sign. You gotta do some algebra to get the answer. Now, let me ask you this. Is this problem on tomorrow's quiz? Okay. You guys are not getting it yet. You guys are just getting it. Here's the practice quiz. Do I see a problem like that over here? No, so no, it's not on the quiz. You guys understand what I do? I make the quiz, and then I just change the numbers. However, the concept of this is the same thing as the sine of 70 degrees, and that concept is on the quiz. Okay, next one. 51 is the next one. Tangent 35 times secant. This book looks like they'd like to use degrees more. But like I said, if you want to succeed in higher math, then you gotta get used to radians. Because like for those of you who are taking physics, you know radian measurement that's the normal way of measuring angles. Okay, now, what do I do? Now, two of them have 35 degrees, and one of them has 55, and notice that they add up to 90 degrees, right? So do you want to change these two to 55 degrees, or you want to change that one to 35 degrees? It doesn't matter, pick one. See, because you want everything to have the same angle measurement so you can use identities, right?
35.
So change this one to 35 degrees. Okay, what is secant of 55 degrees then? Remember, if two angles add up to 90 degrees, then the secant of one is equal to the cosecant of the other. That's cosecant of... See, now they're all 35 degrees, and hopefully we can do the problem now. Yeah, but Mr. Burger, I don't know what to do. Well, okay, if you don't know what to do, if you ever get stuck in problems, okay, like, Mr. Park, I just don't like tangent, cotangent, secant, and cosecant. I just don't like it. Okay? So if you don't like what you see, change everything to sines and cosines. Go back to the basics. Everything is based on sine and cosine. What is tangent? Sine over cosine. Okay. What is cosecant? 1 over sine. Yeah, you have to get these down, people, and of course cosine is just cosine. See, if you change everything to cosines and sines, can you do this problem now?
Yeah.
Yeah. This cancels this cancels this, and if everything cancels out, the answer is, rhymes with bun. 1. Who said 0? You're telling me 3/5 times 5/3, everything cancels out, 0. No, it rhymes with bun, 1. Okay, let's erase this, and now we're on 50. See, isn't it kind of fun? Who said no? Go to your room. 55. Given that sine 30 is equal to 1/2, that's a dumb, that's a number we're supposed to know. Use trigonometric identities to find the values of the following. Cosine 60, B. Cosine squared 30, C. Cosecant pi over 6, and D. Secant of pi over 3. Now actually, I don't care how you do it. See, this is like the speed quiz right here. I don't, forget their directions. Just compute these numbers, okay? Okay, cosine of 60 degrees. This is like today's speed quiz. Where is 60 degrees? Or is that the problem? We don't know where it is. It's right there, okay? What is the x coordinate of that point? That's what cosine is, right? So you make the triangle, and again, in a 30, 60, 90 triangle, that's a half, and that's √3/2, right? The small one is 1/2, and the big one is √3/2. So what is the x coordinate of that point? Yeah, 1/2, because you gotta go 1/2 to the right. That's all you gotta do. Okay, now, cosine squared 30 means cosine of 30 squared. Okay, now where is 30 degrees? It's over here. So if I make the triangle, see how like there's a long leg and a short leg? This is √3/2, and that's 1/2. So what is the x coordinate of that point? Cosine is the x coordinate. √3/2. So what is √3/2 squared? 3/4, right? Bam! Okay, pi over 6. Pi over 6 is the same as 30 degrees, right? Okay, so that same thing here. So cosecant is the reciprocal of sine. Okay? So sine is the y coordinate. What's the y coordinate of that point? How much did I have to go up? Half. Okay? So sine is a half, but cosecant means you gotta flip it over. What's the reciprocal of 1/2? 2. Okay, pi over 3. That's the same thing as 60 degrees, which is right there. Okay, so here's the picture again. Secant is the reciprocal of cosine. Well, we just did it right there, so flip it over. Flip that over. 2. The key to doing the trig values is you gotta know where the angles are. So if that's what you gotta study, that's what you gotta study. Here's a suggestion. Laminate, why don't you guys laminate that unit circle and then put a string on it, and then when you take a shower, here's the shower head. You know, you put it on the shower head like that. So then when you're shampooing your hair, you can just keep looking at it. You don't shampoo your hair. You don't use soap either. That's what I thought. What are you talking about? What? It seems like you go.
Rob, that's some rationale.
Is that a math joke or something? 57, same thing. Okay. Oh, I get. Okay, see this one now. You got to use identities. See, because 4. See that's not a number that I know, right? Okay, use trig identities to compute the following: secant squared theta, b cotangent theta, c cotangent of pi over 2 minus theta, and d cosecant squared theta. Okay, now they actually want you to use identities, okay? Well, do I know an identity that has secant squared theta in it? Which one of, look here, right here. Which of these 3 has secant squared theta in it? That one. So what is secant squared theta equal to? 1 plus tangent squared theta. Hey, but tangent theta is 4, so you just plug in 4 there. So you get 1 plus 4 squared, which is what? Say what? 1 plus 16, 17. Okay, now, what is cotangent theta? Isn't that just the reciprocal of tangent? Okay, so if tangent is 4, what is cotangent? Flip it over. We cannot flip over 4 over 1? Okay, thank you. I didn't hear anything. And then, what is the cotangent of pi over 2 minus theta? That's the cofunction identity. What did we learn? Cotangent of pi over 2 minus theta is? No. It's tangent theta. Okay, here, let me point to it then. Look right here. Cotangent of pi over 2 minus theta is tangent theta. When 2 angles add up to 90 degrees, pi over 2 is 90 degrees, people. Okay? Don't these 2 add up to 90 degrees? Pi over, okay, look, what is pi over 2 minus theta plus theta? Add these 2 together. Here, I'll write it down for your viewing pleasure. What happens if I add these 2 together? These cancel out, what do you get? Pi over 2, which is 90 degrees. So these 2 angles add up to 90 degrees. Therefore, the cotangent of one is the tangent of the other. That's what the cofunction identities are. And then, of course, tangent theta, we know is 4. Okay, cosecant squared theta. Is there an identity that has cosecant squared theta in it? Yes, one of the Pythagorean identities. And what is it?
Cosecant squared theta plus.
Cotangent squared theta plus 1. Correct? Are you looking at it? Do we know what cotangent theta is? Yeah, we just figured it out in this problem here. So this is like 1/4 squared, right? Cotangent theta is 1/4 plus 1, which is equal to 1/16 plus 1, which is 16 over 16. So the final answer is 17 over 16. Oh, I get it now, Mr. Park. We need to have those identities memorized. Yes! All of these need to be memorized, except we're going to be learning them little by little, okay? But by the end of next month, all of these are going to be memorized. And then when you go to pre-calculus, they all got to be memorized. You take calculus, and you know there's 4 semesters of calculus, yeah? Let's say you go to college. It depends what you want to major in. What are you thinking of majoring in? And I'll tell you how much calculus you got to take. Okay, there's 4 semesters of calculus, people. Calculus 1, 2, 3, and 4. See, like at ELI, if you take AB calculus, then that's like one semester.
What?
You take BC calculus, that's like 2 semesters. We have 4 people this year that took multivariable calculus. That means they finished BC when they were in 11th grade. Now they're, so I taught them multivariable calculus. But if you want to major in engineering or mathematics, you got to take 4 semesters of calculus. That's what you got to do. Okay, what about other majors? Mr. Park, I want to major in business. Then you need 1 semester of calculus. I want to major in biology. Then you need 2 semesters. Pretty much any Bachelor of Science degree, biology, chemistry, physics, you're going to need 2 semesters of calculus. But actually, if you major in physics, you probably need 4. So most majors require calculus. Even if you want to be an elementary school teacher, you need 1 semester of calculus. The only time you really don't have to take any calculus is like you're going to major in like fine arts or something. Like art, dance, music. Then you just need math 101 or math 100. Math 100 is like just like. Okay, next, 59. Luckily today's lesson is easy. I just did 59. No, I did 57. Okay, this is the same problem with a different thingy. Cosecant theta is for, use trig identities to find the following. B, cotangent squared theta. By the way, when is the next test? Secant. Oh, now they use degrees. 90 degrees minus theta. And B, secant squared theta. Okay, here we go. Okay, if cosecant theta is 4, how do I find sine theta? Well, what's the relationship between sine and cosecant? They're reciprocals of each other. So if you know cosecant, how do you find sine? You just flip it over. This is like 4 over 1. Flip it. Huli. 1/4. See, that was easy. Okay, cotangent squared theta. Is there an identity for that? Yeah. Look, here's the identity, but you gotta, like I told you last night, you gotta be able to move it around. So what is cotangent squared theta equal to? Cosecant squared theta minus 1. You gotta move the 1 to the other side. Hey, but cosecant theta is 4. So remember, cosecant squared theta means cosecant theta squared. So put the 4 in there. 16 minus 1, 15. Okay, secant of 90 minus theta. What is that equal to? What's the cofunction identity for secant? When 2 angles add up to 90 degrees, this and this adds up to 90 degrees, then the secant of 1 is equal to the cosecant of the other. Hey, but that's 4! So that one's easy. Okay, but what about Mr. Park? If cosecant theta is 4, how do I figure out secant theta? Now here's one that we never had yet. Okay, I'll just tell you, the fastest way to do it is to draw a triangle and use SOHCAHTOA. Okay? So here's an angle. Because this one, I'm not sure. Yeah, I guess we could use identities, but I think it's easier just to draw a triangle. Here, watch it. Cosecant theta is 1/4. That means the same thing as sine theta is 1/4, right? Like this. Now, isn't sine so opposite over hypotenuse? So sine theta is opposite over hypotenuse. Okay? If you use the Pythagorean Theorem, what is the length of this side? Okay, some people can do it. If you can't do it, then call that x, and then use the Pythagorean Theorem. X squared plus 1 squared equal 4 squared. X squared plus 1 equals 16. X squared equal 15. X equal root 15. So, how do you find secant theta? Well, secant theta is the reciprocal of cosine theta, right? Now look at this picture. What is cosine theta? Ka. Adjacent over hypotenuse. So if that's what cosine theta is equal to, what is secant theta equal to? Flip it over. 4 over root 15. But then you gotta square it. So 4 over root 15 squared, what does that come out to? 16 over 50. Now that's the way I would do the problem. Now your book, I'm not sure, I think your book probably wanted you to do this. Secant squared theta is 1 over cosine squared, correct? And is there an identity for cosine squared? What is it? Let me point to it. Look at this Pythagorean identity right there. What is cosine squared?
Cosine squared.
No, move it around, move it around.
1 minus
1 minus sine squared. Oh, but I know sine, Mr. Park, look, sine is 1/4. So 1 over 1 minus 1/4 squared. Okay, 1 minus 1/16. What is 1 minus 1/16? I'll give you a hint, that's 16 over 16. 15/16. And then when you divide by a fraction, that's like multiplying by the reciprocal. So that's 16 over 15. Isn't that the same answer? Yeah, it is. But I'm thinking this is what your book wanted you to do, but to me, this way is faster. But whatever. You know, when you do mathematics, there's so many different ways to do the problem. You want to find the most efficient way. You don't have to do it the book way. The book way is not always the best way. And finally, 63. Is this more of the same? If sine theta is equal to 0.3, what is the exact value of sine theta plus cosine of pi over 2 minus theta? Okay, now this one's easy. What is this equal to? Sine theta, right? Right? When two angles add up to 90 degrees, the cosine of one is the sine of the other. That's the cofunction identity. And what is sine theta plus sine theta? What is gorilla plus gorilla? 2 gorilla. And do we know what sine theta is? Yeah, it's 0.3. So what is 2 times 0.3? 0.6. So see how they give you problems? They want you to look and use identities. Look for and use identities. Okay, now tonight's homework is 7.5, I believe. Okay, well, let's look at it. Trigonometry assignment. Tonight's homework is 7.5. So the first test, you know, the largest part of the test is going to be you're going to have to know your trig values and then your identities. So tonight's homework, we're going to do these 3 identities right here.
Cosine negative theta.
Yes. Okay, and you know what? I can teach that to you in 5 minutes. So luckily today's lesson is easy. Okay, so this is what we need to do. Cosine theta, negative theta, is equal to what? Sine of negative theta is equal to what? And tangent of negative theta is equal to what? Actually, you only need the first 2 because again, once you know the sine and cosine, you can figure out all the others, right? Okay, but all you have to do is look at the unit circle. If this is angle theta right here, where would negative theta be? Remember, how do you get negative angles? You got to measure it clockwise, right? So if this is angle theta, it could be any angle, like 30 degrees. Where would negative theta be? You just go the same amount, except you go clockwise. It would be down here. See? It's the same angle, except you're going clockwise. Remember, counterclockwise is the positive direction, clockwise is the negative direction. So what would the coordinates of this point be? Remember, if you measure off an angle, cosine is the x-coordinate, sine is the y-coordinate. That's the whole premise of trigonometry, people. So if this angle is negative theta, what are the coordinates of this point? Cosine of negative theta, sine of negative theta. It doesn't matter what angle it is. Cosine is the x, sine is the y. No matter, you can have a 53-degree angle, a negative 27-degree angle, it doesn't matter. Now, just look at, my picture is kind of ugly today, but look. What can you say about the x-coordinate of this point and the x-coordinate of that point?
It's the same.
They're the same, right? Because to get to this point, you have to go this much to the right, right? To get to this point, you have to go the same amount to the right. So would you agree that this x-coordinate is the same as that x-coordinate? Yep. And that's how you get this identity right here. Cosine of negative theta is equal to cosine theta. Okay, now look at this picture. What can you say about the y-coordinate of this point and the y coordinate of that point. Look, this one you gotta go up, this one you gotta go down, except the same distance, right? So what can you say about that and that? It's just like this. If you have the point 3, 2 here, and 3, -2 there, right? Look, it's the same distance. What can you say about the y coordinate there and the y coordinate there? They're opposite of each other, right? So what can you say about the y coordinate there and the y coordinate there? They're opposites of each other. So that means this is the opposite of that. And that's how you get this identity here. Sine of negative theta is equal to negative sine theta. Because cosine is the x-coordinate of these 2 points are the same. You go the same amount to the right. The y-coordinates are opposite because one is positive and one is negative, right? Now, once you get these two, how do you get all the rest? You use your identities, okay? So here, I'm going to write it all out, but ultimately you just want to memorize it, okay? What is tangent equal to? What's your basic identity? Sine over cosine. Okay? And what is sine of negative theta? We just learned it right here. Negative sine theta. And what is cosine of negative theta? We just learned it up there. Cosine theta. So what is this equal to then? Negative. What is sine over cosine? Tangent theta. So tangent of negative theta is negative tan theta. And that's what you have here. Look. See? Okay, so that's tonight's homework right there. That's what you gotta know. Okay, so tonight's homework, I need assignments. Oh, we're taking a long time, man. Okay, so tonight's homework, you gotta do 9 through 59. 7.5. So this is the last section that we're gonna cover before the first test. Okay, so basically you gotta use, so what did I say? 9 through 50 something. 59. See, so tonight's homework is just more of the same. Okay, the first section is, okay, here. I'll do a problem, I'll do number 22. This is just more of the same, so just more practice. Cosine of 400, we're not even using what we just learned. Just more of the same. Okay, Mr. Park, this angle is bigger than 360 degrees, what do I do? You guys should know what to do already. Subtract multiples of 360 degrees until you get it to an angle that you can work with. So what would be a good multiple of 360 to subtract from this? 360, and what do you get? 60 degrees, is that an angle we know?
Yes.
You bet your sweet 50 it is. Where is 60 degrees? It's right there. What? Okay, make the triangle. This is a half. This is root 3 over 2. What's the x coordinate of that point? Half. It's easy. Okay, and then the next problems. Use the even odd properties. That's what these are. These are called even odd properties. That's what the book calls them. Now, when you took Algebra 2, did you guys learn about even and odd functions?
Yeah.
I'm just in 2A.
I don't know.
Okay, I'm going to explain why the book calls it even odd. What is the definition of an even function? F of negative x equals f of x. Does that even sound familiar from Algebra 2A? What is an odd function? F of negative x equals negative f of x. Yes or no? We learned it or we didn't? Well, I think you did learn it, but you probably forgot. So why do we call this the odd even properties? Because look, cosine of negative x equals cosine x. It's an even function. Sine of negative x equals negative sine x. That means sine is an odd function. Tangent of negative x equals negative tangent x. That's this one. That means it's an odd function. That's why the book calls it the even odd properties. Okay? Anyway, let me do one of the problems tonight. Let's do 38, since you have to do 37. Cosine of negative 30 degrees. Well, according to what we just learned, what is this equal to? Cosine of 30 degrees, right? cosine of negative theta is equal to cosine theta. And is that an angle I'm supposed to know?
Yeah.
Yeah. Now, if you wanted to, you could have added 360 to that, right? Right? Remember, you can add or subtract three multiples of 360. So if you want to, you can add 360 to that, and you would get cosine of 330 degrees. I don't like that one, Mr. Park. I only like the ones in the first quadrant. Yeah, most students do. Okay? So why not use the even odd? So instead of doing this, just change it to this. Okay, where is 30 degrees? It's right there. So if I make the triangle, this is root 3 over 2, and that's 1/2, right? So what is the x coordinate of that point?
Root 2.
There you go. See, we're getting it. See, it takes a while to sink in, but you gotta keep working at it. Okay, let's do something with sine or tangent. How about, let's do 54 next. 54. Cosecant of negative pi over 3. Now, when you do cosecant, you should be thinking sine and then you flip it over, right? So what is the sine of negative pi over 3? Well, according to the even odd stuff we just learned right here, what is the sine of negative pi over 3? Negative sine pi over 3. Now, if you wanted, you could add 2 pi to that, and you would get 5 pi over 3, but I don't like that one, Mr. Pi. Okay, and where is pi over 3? That's like right here, it's the 60-degree angle. This is a half, this is root 3 over 2. So what is the y coordinate of that point?
Root 3 over 2.
Root 3 over 2. So that's what the sine is, but they want cosecant, so you gotta flip it over. Flip it over.
2 over root 3.
Negative 2 over root 3. Bad. So again, it all comes back to, do you know your trig values? After you apply the identity, you gotta know your trig values, right? All right, so that's the last thing we're gonna learn. So basically, the test is gonna be like tomorrow's quiz plus what we just learned here. So this test is not that hard. No, it's not. So what should be the, what's the main thing you should be focused on then?
Learn the trig values.
Yeah, no, that's done already, you should have. No, it's a practice quiz. We got a 20-point quiz, people. This is like 4 homeworks. Do these problems. Make sure you, if you can do these problems, there's no reason why you can't get a 20 and a 20 and a 20. I don't know. You guys will probably be 15. Whatever, Daddy.